Hello and welcome to the Conversation Weekly. We're taking a short break in August to give our team a little bit of a vacation, but we don't want to cut you guys off from the good stuff. So, over the next couple of weeks, our episodes are going to feature extended cuts from some of our favorite interviews from the last year. This week, we're going to bring you back to an episode we did about an ingenious new conservation technique to protect endangered birds. In many places, bird populations are plummeting, in part due to hungry and often invasive predators. This is not an easy problem for conservation biologists to solve. You either gotta kill the predators, which is actually really hard and also kind of questionable, or you need to protect the nests by building in and damaging the environment. But Katherine Price is part of a team of researchers who found a better way. They use misinformation in the form of fake smells to fool predators into leaving bird nests alone. This is just the best kind of conservation biology. It's kind of an outrageous idea, but it plays the ecological theory of resource efficiency and animal biology like a fiddle. And the result is fantastically interesting and, more importantly, effective. So get ready to get your hands a little bit smelly and enjoy.
My name's Katherine Price. I'm a postdoctoral researcher at the University of Sydney in Australia.
And you study wildlife, do you not?
I do, yep. I worked in the Conservation Agency in New South Wales for quite a few years, and that got me very interested and I guess kind of concerned in how we protect threatened species in particular. Like, are we doing it in ways that are effective, and can we improve those ways? And that led me to go back to uni and do a PhD.
When you were working in conservation, when you were going back to school, what motivated you to do this?
Yeah, so, well, in Australia and in New Zealand, a lot of birds, particularly ground nesting birds, are in decline, basically. They are constantly losing their nests and losing their chicks from predators. And in Australia, Europeans brought over a whole lot of species, things like foxes and cats. And the birds that we have here, and also actually in New Zealand and other parts of the Pacific, they didn't evolve with these predators. New Zealand has this terrible problem with introduced predators because they have no native mammals other than a bat. So their animals are just being absolutely destroyed. In Australia, I think it's something like 95 species are threatened by foxes and cats. I think in New Zealand, they've lost something like 57 or 60 species of birds or either endangered or threatened. And at the moment, really all we can do is either try and kill the predator, which is obviously good if you can get rid of all of them, or fence off the birds, somehow. We just kind of were thinking we need some other techniques, really.
I can hear it in your tone. You were just like, ugh, none of this is working. It's bad for the environment. It's hard. What was the idea you guys came up with?
So most predators, in fact, most animals, they have to find food and they have to find it every day. And so they want to be as efficient as possible. They don't want to waste physical effort, but they also don't want to waste their headspace. So they use what we call rules of thumb. They use clues as to what is going to work based on what's worked for them before. And so animals use smell. It's kind of evolved from the earliest bacteria. It's a really reliable and useful source of information to tell an animal that food is where it should be. Peter Banks, who was my PhD supervisor, he'd kind of been thinking a lot about smell and how predators use smell. And he basically just kind of came up with this crazy idea, what if we put smell everywhere and then it kind of makes it not useful for the predator. In a sense, it's really simple. It's like, well, if predators are finding their food using smell, and, anyone who's had a dog has watched how they've kind of honed in on something using smell, if they keep honing in on a smell and then there's no food there, won't they ignore it? Like if you kept kind of smelling someone having a barbecue next door and going next door and there was no barbecue, eventually you'd stop going. You would start to ignore that smell and use other information to try and find your food. It's just mucking with their minds, mucking with what information they're using and getting them to ignore what is actually the smell of the bird.
Okay, so you came up with this idea, but you needed to test it to see if it actually works, right?
Yeah, because it's a pretty crazy idea. and so that was basically my PhD, was testing the idea and trying to understand which aspects of it we could use. And so we were, I guess, predicting that they would initially be really interested in a new smell that they thought would be linked to food, but really quickly, if they found that it wasn't useful, they would start to ignore it. And that's what we found with rats in the bush around Sydney.
Yeah, so tell me what you did. What was the first experiment? How did you make birds smell?
Well, the first experiment, we had a few fails because initially we thought we could spray birds' smell around. And so I went to a quail farm and collected huge garbage containers full of quail poo and mixed it with water, and it was honestly the most unbelievable stench you've ever come across, and we all almost passed out. It was horrific, and it didn't spray out of a bottle because it was, without wanting to be too gross, pretty chunky and foul. So there were some few kind of revolting moments in the car where you go, God, I hope I don't have a crash, because the police are going to wonder what they're finding in this car. So we realised that wasn't going to work. So in the end, I just got the solid quail poo and divided it up into like 5 or 10 gram spoonfuls, essentially, and froze it and then used that in the field. So there were some funny stories of sort of crawling in and out of the bush. You know, you're wearing gloves, carrying these bags of frozen quail poo and sort of putting it into, we had artificial small fake nests that we'd made out of tennis balls.
And just to clarify, this is to prevent rats from eating quail eggs, correct?
Yes, so this was sort of the first trial to test the idea, to see if the rats would respond when they encountered a smell, but it wasn't necessarily associated with any kind of food.
So did it work?
Yeah, and it worked remarkably well. So it took 7 months, the experiment, and there were many times when I wanted to give up. But yeah, it actually worked when we did the analysis at the end, because we'd controlled for kind of visual cues. So some grids had lots of nests, some grids just had odour. Some we put the eggs out straight away, some we put them out after a week. And what we found when we teased it all apart was that we actually got 65% higher survival of those quail eggs just by putting the smell out for a week before we put the eggs out.
Wow, so just 1 week is all it took to get the rats to start ignoring the smell of quail eggs.
And what it turned out when we looked at the rat activity is it really only took 3 days. They really started ignoring it after 3 days.
You went out and did this on a bigger scale. So can you tell me about your project out in the Mackenzie Basin?
Yeah, so it was fortuitous. We were at a conference and we knew Grant Norbury, who's the lead author of the paper, from previous work, and he's a great guy, amazing scientist. Peter was chatting to him about the results, and he pulled together an amazing team of people from Landcare, and we worked with them and set up this incredible experiment in the Mackenzie Basin, which is in the middle of the South Island of New Zealand. Beautiful, beautiful countryside. It's the area where the rivers have coming off the mountains. You've got these huge braided riverbeds of sort of huge expanses of gravel with mountains in the background. It's just stunning. But it's full of ferrets and stoats and hedgehogs they have introduced over there. There's feral cats and there's rats. So
all the baddies.
All the baddies. And they have these shorebirds that come in and nest on the braided riverbeds, these sort of big expanses of gravel. And the nests are incredibly well camouflaged. You cannot see them at all.
And what kind of species of birds are we talking here?
So the main one we worked on was double-banded plovers, which are these sort of small, they're like the size of your fist kind of thing. And they lay these tiny eggs, which just look like gravel. They also have wrybills, which are another endangered shorebird, which are very similar. And then there were also a bigger bird called the South Island oystercatcher. And all of these birds, the main cause of their decline is that the predators just come in and take the nests, and they'll lose up to 95% of their nests each year. It's amazing there are any left at all, really. when you look at it.
So walk me through what's step one.
Grant works for Landcare. They have a team of chemists. So the first thing was, well, we've got to make bird odour. How do we make bird smell in the quantities that we're going to need? And we went out and caught a couple of these birds and tried to see if we could get the smell off them by rubbing them in towels and without hurting the birds, obviously. And basically they don't actually smell that much from what we could pick up off a towel. So it's like, oh, jeepers, what are we going to do? So we thought, well, what about if we could use just chicken, quail, maybe duck or something like that, get a whole lot of easy-to-obtain bird smells. Could we get the predators to essentially kind of generalise them all together? And so that's what we did. We did some trials in captivity and showed that the predators did do that. If they were exposed to one bird odour, they'd sort of ignore all bird odours. And so that it instantly made it feasible. So the chemists at Landcare were able to essentially just boil up in a solvent chickens and quails. I think these guys are normally used to doing these really fine experiments, and that was stuffing whole birds into these massive kind of jugs of solvent and mixing them up, and extracting these tiny amounts of goop. But it really did smell like the bird. It was amazing.
So you get this bird scent, then what happens?
Mix it into Vaseline, and then we had sites where we knew the birds would come and nest. And so for about a month before we knew the birds would arrive, we were walking back and forth across this landscape and dolloping bird smell every sort of 100 metres throughout this area. I mean, it was pretty labour intensive. We also had cameras monitoring predator behaviour around the bird smell and monitoring the number of predators that were around. I didn't do it the whole time. The guys that did it were so fit by the end of it. Like, it was snowing at times, it was so windy, it would rain, but they just did an amazing, incredible job.
Okay, so did you save the birds? Tell me the results.
It did. It worked. The birds arrived. We had another team of ornithologists, so specialised bird biologists who were monitoring the nests at both the sites where we had odour and the sites where we didn't. And we got it was like a 70% increase.
Wow.
In hatching success. Yeah, pretty much across the board of all the species. So it was pretty astounding because we didn't remove any predators. There was pretty much the same number of predators at the control versus the treatment sites. What we noticed with the predator behaviour is when we first started putting the smell out, the predators are really interested, and then that interest in the odour drops off quite quickly, and then it's fairly low for the rest of the experiment. When the birds arrive, there's a slight uptick in interest, but then it drops off again.
That's a huge increase, 70% increase in hatching success. So are you going to start seeing increases in populations of the birds because of this?
We had some modellers at Landcare look at that and say, well, if you did this and you got this increase each year, does it have a population level kind of benefit? And it really does. So it basically adds about 700 birds to the population over kind of 25 years or something, I think. If you start at kind of 1,000 birds, so you essentially you're getting towards doubling the population.
It's great to have this result. Do you think this might get put into practice other places? Have people contacted you, I guess?
Yeah, so we've had quite a bit of interest, people in Hawaii who are trying to deal with feral pigs taking birds there because Hawaii has a big problem with invasive predators. We've also had people in other parts of America who are actually dealing with crabs and coyotes taking birds. There's in the UK and Europe issues with, so foxes are native there and take shorebirds, so they don't want to cull the foxes. They've also got a whole lot of endangered native predators like pine martens and wolves and things like that. So there's a lot of potential in areas where you've got endangered predators that you obviously don't want to hurt, but you've also got endangered birds that you're trying to protect from them. And that's, I guess, where we see it potentially having really big uptake.
Katherine, thank you so much for taking the time to speak with me today. Thank you for coming up with this, because I can always use a good news conservation story.
Thanks.
If any of our listeners are conservationists and want to get in touch with Katherine Price, she was very happy to speak with anyone interested. You can read the article she co-authored with her colleague Peter Banks about their new study in the Mackenzie Basin by clicking on the link in the show notes. The Conversation Weekly will be back with a new episode on the 26th of August. In the meantime, give us a shout on Twitter at @TC_audio, on Instagram at theconversation.com, or email us, podcast@theconversation.com. The Conversation Weekly is co-produced by Men Mariwani and Gemma Ware, with sound design by Eloise Stevens. Our theme music is by Nita Sarl, and of course, I'm Dan Marino. Thanks for listening, everyone.